Right. Greetings to all great hosts out there. Thank you for joining us. Today we are going to be looking at sketching an exponential function. If you look at the previous sections, we're busy sketching functions. We managed to sketch a linear function. We managed to sketch a parabolic function and a hyperbolic function. Now today I want us to focus mainly on sketching an exponential function. This is not something new to us. It's something that is coming from your grade 11, but it is important for you to be perfect on this concept. So I'm running through these sessions specifically to revise with you what you were supposed to do in grade 11 and recap. In any grade 12 paper, in paper 1, you will be asked to sketch one of the graphs. So it is important for you to be able to sketch our functions. Okay, right. So let's turn to the board and let's try to go through this simple concept. I'm sure you like it. Let's turn to our board and see how this very simple concept. I'm sure you will love it. It's just a refresher course in uh, an exponential equation. Right. I want us to look at the exponential, drawing an exponential graph. Exponential, exponential graph. Okay, drawing an exponential. Okay, now before I start with drawing of an exponential graph, it is important for you to appreciate an exponential function. How do you know that this graph is now exponential? An exponential graph from your lower grades, you identify it by observing that your unknown x is an exponent. So the basic structure of an exponential function at this stage is given by y equals a b x b to the power of x minus p. This is your exponential equation. Okay, this is the basic structure of an exponential equation. Now, to draw an exponential equation, just like any other graph, it is important to know its important features. Right, the importance of an exponential function. Now, the first one, it is the shape. Just like in the shape is important. Okay, and what determines the shape of an exponential graph? The shape is determined by the base, b, which is the base. If b is greater than 1, if your b is greater than 1, the exponential graph is said to be generally increasing. So we say generally it is going to be generally increasing simply by looking at the base. If the base is greater than 1, then the function is going to be what? The function is going to be generally increasing. Say, for instance, just for the, if I put 2 to the power of x, right? The base is 2, which is greater than 1. So this is typical of an increasing exponential graph. Okay, right. Now, let's look at the other one, which is when the base is between 0 and 1. Once the base is between 0 and 1, exponential to be generally decreasing. Okay, we call this generally decreasing. Your function is going to be generally decreasing. So just a quick example there, if equal to, look at this, a half to the the base is a number which is between 0 and 1, so this of a generally decreasing function. Okay, very important. Probably before I proceed, let me just hammer this home. Remember, if you've got an expression like y is equal, the base is true, but that exponent is a negative. Remember, this expression is -1 what x, something of this sort, right? So I'm trying to show you that 2 to the power of -x and half to the power of x, these two are the same, okay, and they will be both generally decreasing. Very, very, very important. Examiners will be playing around with these things. Now that you know that if the base is greater than 1, it's generally increasing. If the base is between 0 and 1, it's generally decreasing. So they'll give you something with a negative exponent like that, but yet the base being a 2. You should always know that. That is also an example of a generally decreasing. Very important. Okay, the next thing is the intercept. Intercepts. What do we know? X intercept and also y is very important, straightforward. Right, let's look at the last aspect there, which is what asymptote. With whether increasing or decreasing, its domain is always what real numbers. What I'm saying is, if I've got something like this, right, and this is generally increasing, domain starts from -infinity to positive infinity, which means x element of all real numbers. Or if it is in something like that, you can also start with infinity right up to positive infinity. That's the domain of an exponential function. So under normal circumstances, the domain of an exponential function stretches from negative infinity to positive infinity. Summarized just as what x of all real numbers. What about its range? Right, range, it varies. If I've got something like this, which is generally decreasing, it means what? The range becomes what? Y greater than Q. If it's also generally increasing, something like that, it's also stretching from the asymptote to positive infinity. So the range will always be y greater than the asymptote, something like that. That's domain and range of an exponential function. Okay, allow me to look at a typical example. This is a very simple graph to draw, very simple. It's not something which is really, really taxing. It's a very simple graph to draw, but you need to master the important features. That's the most important thing. Once you get the important features, then you'll be able. Okay, now I want us to look at a typical example. Right, let's look at example number 1. Right, if you look at example number 1, my example number 1 says sketch the function f of x equal to 2 to the power negative x, 2 to the power negative x minus 8, something like that. Right, I'm supposed to sketch this graph. Now, since x is an exponent, it means this is an exponential equation. And if it's an exponential equation, I have to what? Come up with the important features of an exponential function. Right, so the first thing is the shape. This exponential function, there is a negative exponent. So I can actually put up this as y is the same as a half x minus 8. So it means the base is between 0 and 1. Since the base is between 0 and 1, it means this is a generally decreasing function, something like that. That's how an exponential function decreases. Okay, right, from there, I'm going to calculate the x-intercept, where y is said to be what? 0. So I'm going to come and say y is equal to 2 to the power of negative x minus 8. Remember, f of x is the same as y. So y is 0 now. It means 2 to the power of negative x minus 8. Transpose 8, this becomes 8 equal to the exponential equation. You have to make the bases the same, then you equate the exponent. This is now 2 to the power of 3 equal to 2 to the power of that. So therefore, equate the exponent. This would be 3 equal to negative x divided by negative 1. Therefore, x is equal to negative 3. So that coordinate becomes negative 3 and 0. Okay, I'm now looking at the y-intercept. X is equal to what? 0. So it means this is y equal to 2 to the power of 0 minus 8. Right, 2 to the power of 0 is what? 2 to the power of 0 is 1, and that answer becomes negative 7. So the graph basically cuts at that. Okay, then I'm looking at the horizontal asymptote. My horizontal asymptote is y equal to q. And in this case, if you go back to the function, your q is minus 8. So it means this is going to be y equal to negative 8. I'm now sketching my function. I'm now sketching it. So I can come and say something like that. There you go. So it means this is y, this is x. Right. Whenever you are sketching a function with an asymptote, the first thing is to insert your asymptote. Look at the asymptote that I'm going to insert, y equal to negative 8. So this is going to be y equal to negative 8. It passes through, it's negative 8 there. Where else does it cut? It's negative 7. So I'll come and say negative 7 somewhere there. Where else is it going to cut? At negative 3. There you go. Right. So the graph is going to pass through those coordinates, but approaching the asymptote. Right. Now I'm drawing my sketch. What's going to guide me? It is the shape that we got. It's generally decreasing. When you are decreasing, you always start from the top coming down like that. From the top, it passes through negative 3, passes through negative 7, approaching the asymptote, but it's supposed not to touch it. Okay, there you go. This is the graph that is expected of you. You can label it now f of x. Now, let's look at the domain. I'm done with sketching. What's the domain? You can see that it starts from negative infinity and it ends at positive infinity. Okay, where does the graph start? Where does it end? There you go. Okay, what about the range? The range of this function is going to be y greater than negative 8 from the asymptote to positive infinity. This is the domain and range of f of x. You should also look at the domain and range of the inverse. We did that in the previous classes, and we said what that which restrict the range in f of x will be the restriction for your x in the domain of f inverse. So that would be x greater than that. And that which was the restriction of the domain in f of x becomes the restriction on the range of f inverse. So it means y element of all real numbers. Okay, this is how you come up with how you draw an exponential equation. Okay, let's look at the second example. In the second example, I'm going to try to sketch two functions on the same set of axes. I'm going to call back an hyperbolic function and yet another exponential so that we can all see how they look like on the same set of axes. Okay, right. Now um, let's look at this together. This is now example. Example number 2. Sketch f of x equal to, right, I want us to sketch f of x equal to x minus 1 all over x plus 1, and your g of x, and your g of x is something like this: 2 times three x plus a 1, something like this, on the same set of x's. Okay, right. For me to sketch this, it's a hyperbolic function and an exponential function. Okay, I'm going to start with the hyperbolic function and say my f of x is equal to x minus 1 all over x plus 1. When you're sketching a function, you need to list all the important features. So I'm going to start with the important features of f of x. And you can see that f of x is not in its standard form. So I'm going to convert it first to standard form. So it means y is equal to, remember we said you start by writing the denominator is. I'm trying to split that and write it in its standard form, which is the form a over x minus b plus a q. Okay, so for me to split this, I'm going to say wherever there is x, I'm going to replace it with what? X plus 1, something like that. Then if I replace it like that, I'm going to ask myself, now I've got x plus 1 on this expression, but there it was x minus 1. So what am I supposed to do to plus 1 to come up with minus 1? What should I add to plus 1 in order for me to get my answer is what? Negative 1. Definitely I'm supposed to subtract 2. If you look at this, x plus 1 minus 2, I'll get x minus 1 as a resultant answer there. So it means I did not technically change anything on my expression. So it means I'll come now and say this is x plus 1, put it in one bracket there because I'm trying to split, minus 2 like this. Right, then I'm going to distribute the denominator to each and every term on the numerator. Since I've got a bracket there, it means I now have two terms on the numerator. That will be x plus a 1, x plus 1 minus 2 all over x plus 1, which is 1 minus 2 all over x plus a 1. Okay, which is now in standard form, y is equal to negative 2 all over x plus 1 plus a 1. Good. Right, now I'm supposed to sketch this thing. First, determine the shape. With that which was in general form, you could not come up with a shape easily. That's why I had to change. Very important. So specifically was change. So you follow that. There are a lot of ways to change. You can use synthetic division there. You can use long division as well to break that into two terms. Okay, but I chose to use try and error method. Right. So if the base, if a is less than 0, in this case a is minus 2, therefore the ones are going to be in the second and in the fourth quadrant. Right, now I'm done with the shape. I'll calculate the y-intercept where x is equal to what? 0. This is y equal to negative 2 all over x. I'm going to put 0. then plus 1 plus a 1. So this is going to be equal to y equal to negative 2 all over 1 plus 1. So this answers negative 2 plus 1, which is so I'm going to calculate. I'm now going to come up with your x-intercept. Okay, so if I'm to calculate the x-intercept, allow me to do it there. X-intercept y is equal to what? 0. So you also come and say y is equal to negative 2 all over x plus 1 plus 1. So it means y is a 0, negative 2 all over x plus 1 plus 1. This is going to be negative 1 equal to negative 2 all over x plus 1. Now cross multiply, that will be x plus 1 equal to minus a 2, which is negative x, negative 1 equal to negative 2. That will then be negative x equal to negative 2 plus a 1, which is negative 1. Divide both sides by that. I'll come and say this is what? X, okay, equal to positive 1. So my x-intercept will be that. Now on a hyperbolic function, there are two asymptote, one which is horizontal, which is given by y equal to q, right? Y is equal to, what is your q in this case? If you go to the one in standard form there, it means what? This is going to be plus 1. What about the vertical asymptote? On your vertical asymptote, this is going to be vertical asymptote. It's going to be, you take the denominator part, equate it to 0, because you are looking for x that makes the denominator is 0, and that x becomes negative 1. If you put negative 1 on the denominator part of the original expression, or the one in standard form, you realize that the denominator becomes 0. So these are the important features, right? Allow me to draw it there. Allow me to draw this there conveniently so that I can also come up with the important features of an exponential function. There you go, right? So if I am to label, this is y and this is x, right? I'm now inserting. You can see that every time when you are sketching a hyperbolic function, I emphasized this in the previous class, you should always start with what? The asymptote, and the first asymptote, which is vertical there, is what? It's negative 1. That's vertical. There you go. Come and label it. This is x equal to negative 1. Right. I'm also coming to the next one, which is y equal to 1. Your asymptote are supposed to be inserted as dotted lines. Go. This is y equal to positive 1. Okay. Right. After that, I'm now inserting the intercept, x-intercept and y-intercept. Okay, the y-intercept, we can all see that it's negative 0 and negative 1. So I'm going to be 0, negative 1. Then x-intercept is 1 and 0. You go to 1 and 0 somewhere there. So the graph passes through there and it also passes through there. Right, before now I insert my horns, I'll go back to the shape. They say the shape is between the second and the fourth quadrant. I'll come and name my quadrant. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. My horns are supposed to be in the fourth and in the second. In the second, it's going to start, it's just a matter of inserting the horns in the correct quadrants. That is the second quadrant, and the horn is supposed to start from one asymptote to the other, something like that. Okay, I've labeled that. I'll come now to the fourth. The fourth is a bit tricky because I'm supposed to pass through the intercept, because my intercept were in the fourth quadrant. There you go. This is the hyperbolic function with the horns in the second and in the fourth quadrant. Okay, right, now let's come to the next graph, which is g of x. Simple graph, g of x is equal to what? 2 times 3 to the power of x plus a 1. First things first, the shape. What is going to be the shape in this case? My shape, I can see that the base is greater than what? 1. So it means the function is going to be generally increasing. Look at how an exponential function increases. Right now from there, I'll calculate the intercept. X-intercept, y is a 0. I'll go back and say y is equal to 2 times 3 to the power of x plus a 1. Right, I'll put y, substitute y for the 0. This is 2 times the 3x plus a 1. Transpose 1. This is negative 1 equal to 2 times 3 to the power of what? X. Okay, divide by 2, divide by 2. This is going to be negative a half equal to 3 to the power of x. That's exponential. I'm trying to make the bases the same. But my biggest problem is the left-hand side is a negative and the right-hand side is a positive. So it means there is no base that I can ever put there. If you want, you can apply logarithms now that you've covered them. You see that this will be a logarithm of a negative number, right? So we can say log of a negative half is equal to log of what? 3 to the power of x. And this becomes undefined. So I'll come and say no x-intercept to this graph. Okay, good. Right, now come to the y-intercept. The y-intercept x is also a 0. So I'm going to say this is y equal to what? 2 times 3x plus a 1. But your x is 0 according to that. So it means this is 2 times 3 to the power of 0 plus a 1. So it means I can come and say this is 2 times 1 plus 1. And that answer is supposed to be 3. So this graph will cut at 0 and 3. Lastly, I'm supposed to come up asymptote. What are my horizontal asymptote? Horizontal asymptote is given by y equal to q on an exponential function, and in this case your q is positive 1. I'll come now and say, look at this. The horizontal asymptote, remember we said you always start with the asymptote, and according to this, the horizontal asymptote is also y equal to what? 1. Good, right? My horizontal asymptote is y equal to 1. Fine. Now I'm going to calculate, I'm going to insert the y-intercept, and your y-intercept there, you can see that it passes through 0 and 3. Okay, I don't have an x-intercept. Why? Because the graph was shifted 1 unit up. So the asymptote is actually above the x-axis. Hence, the graph will never touch the x-axis. Okay, I'm now sketching that. We know that this is generally increasing. And since it's generally increasing, you start from the asymptote going up. And if you look at my graph, there you go, there you go, there you go. I'm increasing. There you go, there you go. This is now the function g of x, which is generally increasing exponential function. And this one is f of x, which is a hyperbolic function. Now I've managed to draw my two functions on the same set of x's. Okay, right, that's how you draw an exponential equation. The most important thing is to present the important features, which is the shape, the intercept, and the horizontal asymptote. Thank you for your time. Let's meet in the next lesson when I'll be sketching a hyperbolic function. Thank you. Now that we've managed to sketch an exponential function, we are now going